One more time, find intervals of increase and decrease and any local extrema, and they've given us a bit of a hairball for a function here. To do this one, in case you haven't run into trig derivatives yet, the derivative of cosine x is negative sine x dx. We're going to need that. But it's not the first thing you do, because this function, I'm going to write it slightly differently. This function is 2 cosine 2x all squared. At the outermost level, this function is a second power, and so the power rule is the first thing we should do when we're differentiating it. The derivative of this should be 2 times 2 is 4 cosine 2x to the first power. And now the chain rule says keep going, do the derivative of cosine 2x. And that derivative is, as per this thing, negative sine 2x. And now the chain rule says keep going, do the derivative of what was in that cosine, do the derivative of 2x. And so a 2 pops out of there. So if we collect all that stuff, dy dx. For coefficients, we have a 4, we have a 2, and we have a negative sign. So this is negative 8, and I'm putting the sign first. I'm just used to doing it that way. Sine 2x, cosine 2x. And as usual, when we're finding intervals, we want to find the places where this is undefined, there aren't any, and the places where it equals 0. So where can these things equal 0? Negative 8 never equals 0. Sine 2x can definitely equal 0. And cosine 2x can equal 0. And we have to find all the places where that happens on this interval that they give us from 0 to 3 pi by 4, which is like 135 degrees. So forget about the 2 for a moment. Where does sine equal 0? It could be at 0, which would mean 2x equals 0. It could be at 180 degrees, which would mean 2x equals pi. Or it could be at 360 degrees, which means 2x equals 2 pi. If we solve each of these, we get x equals 0. Well, we can't quite use that because that's out of domain. So good try, but no. If we solve this one, we get x equals pi by 2. That's in our domain, so that's a keeper. And if we do this last one, we get x equals pi, which is actually too high. That's out of domain also. So those were the 3 possibilities that I came up with first, and only one of them actually fits. The others are too low and too high. For cosine, where does cosine equal 0? That can happen when we're at pi by 2. It can happen when we're at 3 pi by 2. And you know what? I have a feeling that's all we're going to need. Because if we solve this first one, we get x equals pi by 4. That's in our domain. We can keep that. And this other one is going to be x equals 3 pi by 4, which is just barely out of domain. So we can't use it. So for critical values, we have 2. We have pi by 4 and pi by 2 are the interesting places on this function. Pi by 4 and pi by 2. I'm going to create some space here, so take your last look at this list. Pi by 2 and pi by 4 are the numbers we have to look at and around. Here's pi by 4. Here's pi by 2. In other words, 45 degrees and 90 degrees. And let's see how our derivative behaves as we look at those. So our derivative is made up of a negative 8, a sine 2x, and a cosine 2x. We'll look at the signs of all of those things individually, and then we'll combine them to find the sign of dy dx. Okay, negative 8's easy. It's negative everywhere. Sine 2x, if we have a small angle here, then let's say it's 20 degrees or something. Double that, you get 40 degrees. Sine 40 is positive. Pi by 4 is 45 degrees. Double that, you get 90. Sine 90 is positive. If you're between pi by 4 and pi by 2, you're at something like 60 degrees. Double that, you get 120 degrees. Sine of that is positive. Pi by 2 is 90 degrees. Double that, you get 180. The sine of 180 is 0. And if you go any higher than that, you get angles past 180 and the sine goes negative. For cosine 2x, if x is like 20 degrees, double that, you get 40. Cosine 40 is positive. Pi by 4 is 45 degrees. Double that, you get 90 degrees. Cosine 90 is 0. In here, where we have something like 60 degrees, double that, you get 120. Cosine 120 is negative. Pi by 2 is 90. Double that, you get 180. Cosine 180 is negative. And if x is like 100 degrees or something like that, double that, you get 200. Cosine 200 is negative. You can pick all kinds of different numbers here. The point is to pick any number that is easy for you to visualize that falls in the appropriate part of the number line. So, if we combine all these things to make our derivative, here we get negative times positive times positive, negative times positive times 0, negative times positive times negative. There's a 0 there. That part's easy. 2 negatives cancel and 1 remains. So, as far as derivative behavior, this function goes decreasing, flat, increasing, flat, decreasing. So we have an interval of increase between pi by 4 and pi by 2. We have intervals of decrease from 0 up to pi by 4, and from pi by 2 up to 3 pi by 4. That's where our domain ends. And for local extrema, apparently we have a local minimum here at pi by 4. Let's see what is going on there. We have a minimum at pi by 4, comma, and what's our y value there? Pi by 4 is 45 degrees, so double that, you get 90. Cosine of 90 is 0. Square that, it's still 0. Double it, it's still 0. So we have a local minimum at 0. Over here, where the function went up, flat, down, that's the top of a hill, or a local max. That happened at pi by 2. And what's our y value there? If you take pi by 2, which is 90 degrees, double it, you get 180. Cosine of 180 is negative 1. Square that, you get positive 1. Double it, you get 2. And that should be our max.